4 cups on a table. 2 pairs. Side by side. A researcher at Harvard lifts 1 cup, shows it's empty, places it back down. And then she waits. The subject looks at the cups, looks at the empty one, looks at the others, and picks. Not randomly, not by luck, by logic. The subject passed this test, scored better than the average 5-year-old, better than some 6-year-olds, better than most children under 8 who had ever been given the same task in the same lab. The subject's name was Griffin. Griffin was a parrot. Here's the test. It's called the 4-cup task. It was designed at Harvard's psychology department not to study animals, but to study human children. To understand exactly when and how children develop the ability to reason through a specific kind of logic called inference by exclusion. The logic works like this. There is a reward somewhere. You know where. You are shown that it is not in one specific location. From this, from knowing where something is not, can you deduce where it must be? This sounds simple. It is not simple. Most 2.5-year-old children fail this task. Not the easy version of it. The version with 4 cups, which requires the child not just to pick the right cup, but to make a probabilistic judgment, certain here, uncertain over there, and understanding the difference between those 2 states simultaneously. Irene Pepperberg, a research associate in Harvard Psychology Department, looked at this test, a test designed to probe the developmental edge of human logical reasoning, and asked a question that most of her colleagues thought was mildly absurd. What if Griffin tried it? Griffin was not Alex. That matters, because Alex, the African gray parrot who spent 30 years with Pepperberg and died in 2007, was in some ways a singular case. Extraordinary. A research subject who produced results so unusual that critics spent years trying to explain them away. Griffin was the next generation, the next bird. Quieter, more methodical, less theatrical than Alex. He had been in the Pepperberg lab since he was a chick. He had been trained using the same model rival technique, the method Pepperberg developed that mirrors how children learn language, through social observation rather than repetitive drilling. He had already passed the 2-cup version of the inference test. Many times. That version, showing a subject that one of 2 cups is empty, and watching them correctly choose the other, had been considered a strong indicator of logical reasoning. Pepperberg had doubts about that interpretation, and those doubts led to Griffin and the 4 cups. Here is the problem Pepperberg was working around. The 2-cup test had been the gold standard for animal intelligence research for years. Animals pass it. Chimps, dogs, parrots, and researchers conclude, inference by exclusion confirmed. But 2 of Pepperberg's colleagues at Harvard, psychologist Susan Carey and her graduate student Shilpa Modi, published a paper arguing that the 2-cup task wasn't actually testing what researchers thought it was testing. Their argument, when a subject sees 1 cup is empty and picks the other, they might not be thinking if it's not here, it must be there. They might simply be thinking not that one, I'll try this one. Default behavior, not deductive reasoning. To distinguish between those 2 possibilities, you need a harder test. The 4-cup task is that harder test. 2 pairs of cups. A reward hidden in 1 cup of each pair. 1 cup from 1 pair revealed to be empty. Now the subject has 2 decisions to make. For the pair where 1 cup was shown empty, the other cup in that pair is the certain choice. The reward is definitely there. For the other pair, where no cup has been revealed, the subject has a 50-50 chance. No more information. Pure probability. A subject who genuinely understands inference by exclusion should pick the certain cup with high accuracy, and should be uncertain should gamble on the 50-50 pair. This is what the test was designed to show. And this is what most human children under 5 cannot consistently do. Griffin sat in front of 4 cups. Pepperberg and her team ran the trials. Griffin had 2 initial attempts at the task and failed both times. 2 separate runs, multiple trials each, below what they needed. Pepperberg didn't give up. She ran additional training, returned to the task, and on the 3rd attempt, Griffin passed. He selected the correct cup on 94% of the trials. 94%. What? The average 5-year-old child in Maudie and Carrie's original study had scored around 60 to 75%. 2.5-year-olds had failed entirely. Griffin, 94%. But Pepperberg was not finished. Because 94% could theoretically still be explained by a simpler strategy. Maybe Griffin had learned to simply pick whichever cup was adjacent to the empty one, without actually reasoning about it. To rule this out, she designed a series of additional trials specifically to eliminate that possibility. Trials where the simple pick the neighbor strategy would produce wrong answers. Griffin didn't fall for it. He wasn't following a rule about which cup to pick based on position. He was tracking the logic of the situation. When the certain cup was available, he chose it. When only the uncertain pair remained, the 50-50 gamble, he gambled sometimes and didn't gamble other times. Pepperberg said something about this that stopped me. She said, basically, we forced him to gamble. A good enough percentage of the time, he gambled. But what was interesting was that if he lost, he wouldn't gamble on the next trial. He learned from losing a bet. He updated his behavior based on probabilistic outcome. That is not a trained response. That is a reasoning system operating on new information. And the 4-cup task was not the only test Griffin passed. In a separate series of experiments at Harvard, researchers showed Griffin 2 cups with different amounts of juice. Then they poured both amounts into new cups, one of which had a false bottom, designed to make both cups appear to hold the same volume. Most people, shown this trick, are fooled. Griffin wasn't. He tracked the hand movements during the pouring. He recognized which cup held more even after the amounts were disguised in visually identical containers. Even when the researchers crossed their arms while pouring, specifically to make the tracking harder, Griffin followed correctly. On tasks measuring liquid volume understanding, he performed at the level of a 6 to 8-year-old child. Not a 2-year-old. Not a chimpanzee at the bottom of the scale. A 6 to 8-year-old child. For context, the classic Piagetian conservation of volume test, the one that established the developmental timeline for when children understand that the amount of liquid doesn't change when you pour it into a differently shaped container, was designed in the 1950s as a cornerstone of developmental psychology. It is one of the most replicated findings in the history of child development. Griffin passed a version of it. I want to be precise about what the research does and does not show. Griffin was one bird. Pepperberg has been scrupulous about not overgeneralizing from one subject. The initial failure of the 4-cup task, 2 failed attempts before the eventual success, matters. It suggests the task was genuinely difficult. It was not easy for Griffin. He required repeated exposure before passing. And the question of what inference by exclusion actually means in a parrot's brain, whether the cognitive mechanism is the same as what produces it in a human child, or whether different neural machinery arrives at the same behavioral output, that question is not resolved by these results. Pepperberg herself has said the study points to flaws in how researchers have been measuring animal intelligence, not just evidence that parrots are cognitively equivalent to children. That is an important nuance. The gold standard test, the 2-cup task, may have been telling researchers less than they thought. The 4-cup task is harder. more revealing. And when Griffin passed it, he didn't just demonstrate his own intelligence. He demonstrated that the field had been working with an instrument that was less precise than it appeared. One parrot passed a children's cognitive test, and in doing so, forced a conversation about whether the test itself was any good. Here is the context. When the 4-cup study was published in 2019, it joined a body of research that had been accumulating for decades. Research showing that African gray parrots could count, categorize, label, ask questions, understand concepts of zero, create novel words for objects they had never encountered. Each new result should have shifted the consensus, and each new result did, slightly, incrementally, against significant institutional resistance. The word bird-brained, meaning stupid, incapable, cognitively primitive, came from the assumption that bird brains were simply smaller, simpler versions of mammalian brains, without the neocortex that primates have, without the architecture that researchers believed was necessary for complex thought. What the last 4 decades of parrot research, and particularly the last 15 years of neuroscience, has shown is that birds developed a different architecture that produces similar cognitive outputs through different means. Not lesser. Different. Griffin passing the 4-cup task is a data point in a much larger argument. The argument is this. The assumptions we built into our tests for animal intelligence were built by researchers who expected animals to fail. When they didn't fail, we had 2 options. Change the animals, or change the test. Pepperberg kept changing the test, made it harder, more precise, designed to rule out simpler explanations. And Griffin kept passing. Let me come back to those 4 cups on a table. A Harvard psychologist lifts 1 cup and shows it's empty. Griffin looks. He is tracking 2 things at once. 1 certainty. 1 probability. He knows the difference between them. Knowing the difference between certainty and probability, between definitely here and maybe here, is the kind of reasoning that took human children, on average, until age 5 to reliably demonstrate. Griffin demonstrated it. I am not making a claim about consciousness. I am not claiming Griffin felt something while he reasoned. I am making a much simpler observation. The task was designed to test a specific cognitive ability. Researchers ran it on human children to establish a developmental baseline. And then, they gave it to a bird. The bird passed. And Pepperberg, who spent her career being told that what she was doing with parrots wasn't real science, that the results weren't meaningful, that birds couldn't do what her data kept showing they could do, watched Griffin pick up the certain cup on 94% of trials. This is really about logic, she said. She was right. It is about logic. And a parrot had it. I want to know, has your parrot ever done something that seemed like it required logic? Not memory, not repetition. Logic, a problem they hadn't encountered before that they solved in a way that surprised you? Drop it in the comments. I read everything. And here is the question that keeps coming back to me. If Griffin had to fail the 4-cup task twice before passing it, if it was genuinely difficult for him, what does that tell us about the difference between something being hard and something being impossible? Because those are 2 very different things. And for a long time, the research treated them the same way. See you in the next one.